Let's go to question 4. So question 4, salts are substances that have many methods of preparation. So you have iron to chloride. Iron to chloride can be prepared by reacting substance X and dilute hydrochloric acid. Okay? Now, which reactant should be in excess? Okay? Which reactant should be in what? In excess. So the reactant that should be in excess is this substance here. This metal. I don't know if it's metal or what. This substance. So we can just say substance X should be in excess. Okay. Oh, we are even asked to give a reason. Okay. Why should the named reactant in A1 above or in A1 be in excess? Okay, so this one should be in excess in order, okay, or in order or to ensure that this acid, hydrochloric acid, to ensure the acid is used completely, okay, during the reaction, okay, during the reaction. Then other questions, question B1, suggest a suitable reactant as substance X. Okay, suggest a suitable reactant as what? Substance X. So now look at this. You need to be very careful here. So since this one is a product, okay, this one is a salt that can be prepared by reacting substance X and hydrochloric acid. So you can hear here, you can see here that there is a hydrochloric acid. So whatever the substance X is, there has to be a metal. Okay, there has to be a metal. Let me show you here. Substance X must be one of the constituents of this metal, this this salt. So since the hydrochloric acid here, there is chloride, then ion should be substance X, or substance X should be ion metal. Check. Hydrochloric acid reacting with the ion, this ion, okay? So one of the chemical properties of acids is that they react with some reactive metals to produce a salt and hydrogen gas. So the chlorine and the ion here will be ion to chloride. Yeah, because here we are told that ion has a valence of what? 2. So we can just say ion to chloride and hydrogen what? Hydrogen gas. I'm just explaining anyway. Check. This is ion to chloride. Ion to chloride. Then this is hydrogen what? Hydrogen gas. Hydrochloric acid. Ion. So the answer here is ion metal. So you can just say here ion metal. Very good. Let's go to the next substance. Write a balanced chemical equation for the reaction between substance X suggested in B1 or here with dilute hydrochloric acid. Nice. We've already written this, answered this question here. Okay, let's just copy it this side and balance the equation. Okay, so we can say substance X, since we've said this ion, so we can just say substance X reacting with hydrochloric acid to form ion to chloride. So since ion has a valence of 2, chlorine is in group 7 has a valence of 1, electron valence of 1, so the 2 will come here, and hydrogen what? Gas. Okay, this one is a solid, it's a metal, since it's a metal solid. This is aqueous, this is a salt, aqueous. Let's check before we say it's a salt. Salts are substances that are many. Yes. Then if this one is a gas, let's balance the equation. So balancing the equation, ion 1, the number of ion atoms of ion on the reactant side here is 1, on the product side is also 1. Now when you look at the number of hydrogen atoms here is 1, here the number of hydrogen atoms is 2. So what you do, since when balancing, use a pencil because the coefficients tend to change. Okay, so let's put a 2 there. The number of chlorine atoms is 2 because of this 2 which is in front, so also here 2. So this equation is what? Balanced. Thank you so much. Let's go to the next question, which is question question 5, B5. Okay, now B5, if you are still together up to this question B5, consider subscribing and liking the video if you are not part of the Nosteg Academy family. So this question is under what question is this? And more concept. Okay, so 10.5 grams of sodium hydroxide was reacted with dilute hydrochloric acid according to the equation. So this is the equation here. Wow. So the first question is balance the given equation. Well, this is simple. So we're going to say sodium hydroxide, since it's in aqueous here, reacting with sulfuric acid, H2SO4, aqueous as well, to form sodium sulfate, okay, aqueous, and water, H2O, liquid. Then balancing this equation, okay, balancing this equation is very simple. We're going to say how many number of atoms of sodium do we have on the reactant side? This side is 1, this side 2. So we're going to change this one to a 2. Okay, like this, we put a 2. Then we go to the next. How many? So we go to the next element, which is oxygen. How many atoms of oxygen do we have on the reactant side? We have, this is 2 plus 4. So we have 6 on the reactant side. How about on the product side? We have 4 plus 1, 5. So we can put a 2 here where there is water here in front, so that it becomes 6 as well. Okay, take note that the number of hydrogen atoms will be affected, but no problem. Let's just proceed. The number of atoms of sulfur here is 1, here is also 1. So what hydrogen has been affected, only hydrogen has been what? Affected. So what we can do, what we do here is check, since here there are 4 atoms of this number of hydrogen have been affected. No. So it has balanced. No, it has balanced. So hydrogen 2 plus 2, 4. Here 2 plus 2, 4. So everything now is balanced. Let's go to the next what? Next question. Okay. Next question. B1. Use the balanced chemical equation to calculate the mass of sodium to calculate the mass of sodium sulfate formed. Wow. Now, the balanced chemical equation. So let's get the two compounds that are involved. So we are given 10.5 grams of sodium hydroxide. So we're going to use 2 moles of sodium hydroxide. Okay, 2. What else? We're asked to calculate the mass of sodium sulfate. Sodium, so it will be sodium sulfate. Okay, like this. Now we have to be very careful here. We're going to say first we need to know the number of the relative molecular mass. Okay, the relative molecular mass of sodium hydroxide and the sodium sulfate. So when you look at relative molecular mass of sodium hydroxide, since we have a 2 here, it's going to be hydrogen. How many atoms of hydrogen? Because of this 2, you have 2. All right, 2 times the mass number, which is 1. Then we go to oxygen. Oxygen, we have also 2. The mass number is 16. Sodium is also 2 times 23. So when you add this side, we're going to have a 2. When we multiply, I mean 2 times 16, 32. 2 times 23 is 46. And then we add. When we add here, we're going to have, this is 2 plus 32 plus 48. This is giving me 80. Okay, 80. So here we're going to use 80. Okay, 80. How about for sodium sulfate? Okay, let's do as well for sodium what? Let's calculate for sodium sulfate as well. So since we have 1 here, so we'll only consider the number of atoms that are here. So 4 times 16, then sulfur is 1 times, is it 32? Let me check on the predictable so that you don't make mistake. Okay, the sulfur, yes, it is 32. Sodium, it is, this is 2, so it will be 2 times 23. Okay, so when we multiply here and add, we are going to have 142. Since because of space here, we're going to have 142. Okay, so 16 times 4 is 64. This is 32. This is 46. When you add, you're going to have 142. So we're going to use 142 here. 142. Then listen and listen very carefully. Here, you ask yourself, what mass of sodium hydroxide are we given here? They are given 10.5 grams. Okay, then what mass of sodium sulfate? We don't know is the one we want to what? We are calculating. Then we cross multiply. When we cross multiply this times this, it will be 80x. Okay, it will be what? 80x is equals to 10.5 grams multiplied by 142. Then we divide by 80, even this side by what? By 80. The 8 and the 80 will cancel. And then you have x is equals to, so when you punch these on the calculator, we're going to have 18.64. Correct to 2 decimal places, 6.4 grams. Okay, this is the grams of, this is the mass of sodium sulfate. Okay, sodium sulfate. Okay, so that's it to this question. So I was explaining, that's why I've taken time here explaining how we get the 80 and the 142, how to get the relative atomic mass, molecular mass, I mean. or formula mass. Then the question Roman number 2, B2, what type of reaction is involved in the equation? This is a base and this is an acid. So this is neutralization reaction. Okay, so it is neutralization reaction. Neutralization reaction. Okay, that's what question B5. Let's go to B6. B6, this is under periodic table. This is under periodic table. So the question reads, an element A is in group 1 of the periodic table. Okay. Another element N is in group 7. Nice. Write one property of the compound formed when element A and N react. Now, you need to know first the type of compound that is formed, the name of the compound. Oh, yes, the type of compound, I mean. So elements A are metals and element N are non-metals. So when metals and non-metals are involved in a chemical bonding, the bonding is called ionic bonding or electrovalent bonding. Now, the compound formed has a lot of properties. Okay, properties. Number 1, you can say it is made up of positively and negatively charged ions, or negatively and positively charged ions. You can say the compound formed in conducting electricity in molten state or aqueous state. It has high boiling and melting point. Okay, high boiling and so there are a lot. So we can just write 1. So let's just say the compound has high boiling and melting points. Okay, there are a lot. Okay, you need to know a number of properties of ionic compounds. What type of bonding exists in the compound formed when the two elements react? Chemistry is very simple, guys. As long as you understand the topic or understand the lesson, okay, you understand everything, go through different past papers and the chemistry will be nice. So you see, as I was explaining here, I've even answered this question. So the type of bonding is ionic bonding. Ionic bonding. You can say electrovalent bonding. Let's just write ionic bonding. Since you know this is group 1 elements are metals and group 7 elements are non-metals. How does the reactivity of elements in group 1 differ from elements of group from that of elements in group what? In group 7. You should know that group 1 elements, okay, group 1 elements, their reactivity increases as you go down the group. The trend in reactivity of group 1 elements increases as you go down the group. So group 1 elements, I would have said it, okay, it's okay. Group 1 elements, their reactivity increases, okay, increases down the group, increases down the group, Okay, whereas group 7 increases up the group. So meaning the most reactive element in group 1 is the element which is down in period in group 1, which is francium. Then the element which is most reactive in group 7, it is fluorine. Okay, fluorine. Are we done with this question? Yes, just 4 marks.